Hello. Hey, Tapiwe. Tapiwa.
Hello, how are you?
Yes.
Fine. I see you there.
Yes, I'm here. I have made you co-host,
Okay.
so everything's set up. Everything's set up and cool on my side. I'm just gonna share to YouTube or live on YouTube, and then you can start at 4 o'clock.
Okay, that's fine.
Perfect. Thank you so much, Tapiwa.
Okay, you're welcome.
Thank
It's
you.
working too.
Thank you.
Put in the files.
Okay, hello everyone. Welcome to grade 10 Miss Lit with Safiwa. Today we want to start on a new topic. Hopefully everyone can hear me clearly. Can you hear me, guys? Can you hear me? Okay, so today we want to start on a new topic that is on probability. Yeah, hello Musa, how are you? Okay, so as I was saying, we want to start on a new topic today on probability. Okay, this is a new topic. You will mean it. You will mean it when you look at yeah. I miss you too, guys. I miss you too. Eh? Okay, so we're going to look at probability. This is going to be a really important topic as you will see. You meet it in your grade 10, you meet it in your grade 11. Okay, so as always, I don't always want to talk. I just want to do the example so that you see how we can do it, how we can work it out. Okay, so probability. What you need to remember about probability is probability is just a measure of likeliness of an event happening. That is the likelihood of an event happening. That is probability. And probability is measured from a scale of 0 to 1. That is, we are saying probability is a ratio. It ranges from 0 to 1. It cannot exceed 1. It cannot be below or 0. So it ranges from 0 to 1. 0 being the worst. That is when an event is said to have a probability of 0, we say that event is very unlikely to happen. Then when we say event has got a probability of 1, we mean that that event is very likely to happen. Okay, so that is what we are going to look at. That is what we are going to look at. Okay, so we are going to look at probability. The best way to look at these chapters is just to look at the questions and work out how to do the question. Okay, so let's look at this activity I have for you here. So you're supposed to work in groups over this. We're just going to read and familiarize ourselves with what is happening. Okay. Okay, so I have an event here, becoming familiar with probability scale, the scale that we talked about, that ranges from 0 to 1. Maybe I need to include that, 0 to 1, meaning it is a ratio. Okay, we have 1. Think about 5 events that have different, think about 5 events that have different chances of happening. Think about 5 events that have different chances of happening. So you can think about events that have 5 chances of happening. I can give you a clue. Let's take, for example, at your school, there are 5 grade 10 classes. There are 5 grade 10 classes. So the probability of you being in one of those classes, the probability of you being in one of those classes, the probability of me being able to figure out if you are in one of those classes. Let's say you have grade 10A, you have grade 10B, you have grade 10C, you have grade 10D, and you have grade 10E. The probability of you being in one of these 5 classes is 1 over 5. It's likely that I'm going to choose the chances of me getting choosing the correct class that you are in. It's 1.5. Okay, that is what we mean when we say an event. So we are just getting started. Don't worry, we are just getting started. Don't worry. Don't worry yourself. Okay, so think about 5 events that have different chances of happening. think about 5 classes that have different chances of happening. That is what we want to talk about. Okay, so let's look at this part here. Draw a probability scale with all word labels written on it. So you can use word labels. So for example, learners should come up with their own meaningful description. So I've just given you mine. So you're supposed to think of your own description that you think qualifies to be here. And my example of classes is equal probabilities of happening. But we can further give information to the class. If a class has more students, that class has more chances of being chosen. Okay, so you will see when you look at when we look at questions. Okay, let's look at C. C is saying discuss where these events should go on the probability scale and come to an agreement in your group. You might find that different people have different ideas about what the words on the scale mean. Okay, so we have here, this question is a group work question. So I just want to get you into the subject, to get you have an idea. Okay. Let's look at a different question. Let's look at question number 2 here. Question number 2 is saying, place these events on your probability scale. A 1 in 10 chances of pulling a red t-shirt out of your cupboard without looking. A 1 in 10 chances of pulling a red shirt out of your cupboard without looking. Okay, so as we have said probability are chances of an event happening. So in this instance, in this example, the event is pulling out a red shirt. So we want to figure out what is the probability of pulling out a red t-shirt. Okay. Okay, guys, I'll try slowing down, but I'm just introducing the topic. You will get to understand what I'm saying when we look at the questions. When we look at the questions that we will be dealing with. Okay, so I will try to slow down, guys. Don't worry. Okay. Then we have part B here. Part B is saying any 80% chance of a rain. That is what we are saying here. 80% chance of a rain. 80% chance of a rain. We said a probability is a value between 0 and 1. And we have been told that there is an 80% chance that it will rain. Remember, guys, when we talked about percentage, we said percentage means over 100. So whenever we have 80%, this is the same as saying 80 over 100, right? So we want a number that is between 0 and 1. So when we divide, we'll get what? We get 0.8. 0.8 is the value between 0 and 1, right? So 0.8 is the probability that it will rain. Okay, guys. Okay, and looking at part C is the same thing. We are looking for a number between 0 and 1, and we have been told that a 1 over 20 chance of having twins. There is a 1 over 20 chance of having twins. So we are saying in 20 births, there is a probability that we are going to have one birth that has got twins. So we are just saying 1 over 20, which is equal to 20 into 20, that's 1. 20 into 1, we got 0. Then we say 0 over what? 0 over 1 divided by 20. So we are looking for a number between 0 and 1. So since we are looking for a number between 0 and 1, we will get 0.05 when we say 1 over 20. So the probability of having twins is 0.05. Okay, so same applies with part D. Part D is saying a 1 in a million chance of being struck by lightning. A 1 in a million chance of being struck by lightning. So what are we saying when we say a 1 in a million chance of being struck by lightning? We are saying 1 in what? In a million. That is situation like this. This is 1 in a million. Okay. You need another 0. So this is 1 in a million. So we are saying 1 divided by a million. This is the chance that a person will be struck by lightning. Okay, so we are basically just saying it is 0.0000001. This is the chance that someone is going to be struck by lightning. Okay, so you can just write it as that, or you can write it as that. Okay, so I was just trying to make you appreciate that when we are talking about probability, we are talking about a number that ranges from 0 to 1. All these examples that I have been giving you, all these examples that I have been showing you, they are trying to show us that the probability is a ratio that ranges from 0 to 1. When it is close to 1, the event is likely to happen. When it falls close to 0, the event is not likely to happen. And when it falls in the middle, like 0.5, we are now saying the chances of the event happening are 50-50. That's why we are saying 50-50. The chances of that event happening are not favorable to any. The chances of the event happening are the same as the chances of not happening. For example, when you toss a coin, when you toss an unbiased coin, because there are some coins that are biased towards one side. So when we toss a fair coin, the probability that we will get a tail is half, and the probability that we will get a head is half, right? So whenever we toss a coin, we would expect either a head or a tail. The chances of getting those odds are the same. That is what we are talking about when we are talking about probability. So they have written here, write these probability as decimal numbers, as percentages. I'm sure you are able to do that, guys. You're able to change these values. Sorry, am I speaking really fast, guys? Okay, so I really need to slow down. Okay, so as I was saying, as I have been saying, when we are talking about probabilities, we are looking for a number between 0 and 1. That is the probability. When we are being asked to find probability, we are looking for a number between 0 and 1. When probability of an event is closer to 0, that event is less likely to happen. When the probability of a number is closer to 0, like this situation here, this probability is really close to 0. It's 0.05. It is really close to 0. So the probability of having twins, remember this is the situation when we are talking about twins. So the probability of having twins is really unlikely. The event of having twins is really unlikely. And so is this one. As you can see, the chances that an individual will be struck by lightning, the chances that an individual will be struck by lightning is really small. That's why we have very little situations. We have recorded very few situations where one is struck by lightning. That's why we are having a very small number. This is a small number, guys. This is a very, very small number. As you can see, it is even closer to 0. So we are saying the probability of being struck by lightning is very unlikely. In comparison to this one, as you can see, 0.8. 0.8 is even close to 1. So this event here is very likely. This event here is very likely in comparison to these two events. Okay, just a tip, guys. That's why people don't usually are not expected to gamble because you never win against the house. There is that rule. You never win against the house. It's not good idea to gamble because you're always losing. The odds of you winning are really, really slim. They are really close to zero. Okay, as you go on further studying with mathematics, you maybe come across this theory about the gambler's rule. The gambler's rule. They call it the gambler's rule because uh, you never win when you gamble. Okay, so that's basically what we are talking about. That's basically what we are talking about. So they have expressed, I'm sure you are able to express a decimal number to a fraction. Okay, so whenever you are given a fraction, if you want to express it as a percentage, you just multiply it 100%. That's how you express a fraction into a percentage. Same applies to a decimal. Given a decimal number, you want to express that decimal number as a percentage. You just take that decimal number, you multiply it by a fraction. Let me just show you a quick example. Let's take, for example, you have this probability of 0.25. You've been asked, you want to convert this probability to a percentage. You want to convert 0.25 to a percentage. How do you do it? You just multiply the probability by what? By 100%. So when you do that, when you say 0.25 multiplied by 100%, I'm sure you know the answer, guys. It's just 25%. So given a fraction, same applies. Let's say, for example, I've been given half. I want to express this as a percentage. I just multiply it by 100%, so I'll get 50%. So 50% and half represent the same probabilities. Okay, so let's just move on to, let's see if we have more questions that can express what we need to look at here. Okay. Okay, let's look at activity 7 here. Activity 7, guys. Let's try to pay attention now. This is the important stuff. This is how we learn. Okay, by example. Okay. Again, it requires us to work in groups. You can work on your own. You can be a group with me. This is our group. Okay. So it says, work in groups to carry out the following experiment and record your results. You will need coins, dice for each group. So we just assume we discuss and see if we can get to the actual answer. Okay. Each of you should flip a coin 20 times. Record your results in a tally table like this. Okay. Okay, let's see if it does it. Okay. Let's see, guys. Calculate the relative frequency of tails by working out the fraction of 20, the decimal fraction, and the percentage. The decimal fraction and the percentage. Calculate the relative frequency of tails by working out the fraction of 20, the decimal fraction, and percentage. Okay, so what you need to do when they are asking you of frequencies, they are asking you the number of times. This is what they want you to do, guys. They want you to toss your coin 20 times. When you toss your coin 20 times, if you have a coin, okay, of course this experiment is not going to happen now, but I have actually done this experiment. So when you do that, when you toss a coin, what you would expect to find is relatively an equal amount of heads as tails. So if you toss a coin 20 times, you would expect 10 heads and 10 tails. But of course, guys, this is not exactly what is going to happen when you toss the coin 20 times. Probably you are going to have a nine heads and 11 tails, or probably you are going to have 8 tails and 12 heads, but that is very close to 0.5. When you say 8 divided by 20, when you say 8 divided by 20, you get 0.4, which is even close. Okay, let me try to explain this. Okay, so guys, we are saying we have we are going to make a tally table. This tally table is going to record each time you toss a coin, you record. Each time you toss a coin, you record. So you are going to record this 20 times. Okay, you're going to record this 20 times. When you record this 20 times, you record the amount of heads, you record the amount of tails, right? So if you would expect, if the coin is unbiased, this is what you would expect. If the coin is fair, this is what you would expect. You would expect an equal number of tails as heads. So you would expect 10 heads and 10 tails. That will make you 10 over 20, that's 0.5. 10 over 20, that's 0.5. So, but what I'm saying is, this is what you would expect. But if you will find out you do this experiment, someone is going to get 8 heads, 12 tails. And another is going to get 7 heads, 13 tails. But those numbers, when you say 7 divided by 20, get a 0.35. 0.35 here, of course, when you say 0.35, it's even, now it's not even close to 0.5. But at the same time, when you say 8 divided by 20, you get 0.4. 0.4 is close to 0.5. So you should expect values like that, guys. You should expect values like that. Okay, so let's move on to part B. Part B says, how does this compare to the theoretical probability of 50%? 50% is what we would expect. Theoretically, this is what we would expect. But remember, guys, this is a random event. Random event, the chances of each event happening is random. It doesn't depend on previous event. So when you toss a coin and you find that it is a head, when you toss again that same coin, the probability of you getting a head again does not depend on the probability that you got a head previously. I'm not sure if you're getting me there. It means these two events are independent. Each event you do is even independent of the previous event or the previous outcome. Okay, so you get the clear picture when you look at the examples, guys. Don't worry yourself. Don't worry yourself if it is not clear to you now. You will get the picture when we do more examples and see how we get to the answers. Okay, so let's look at part C. Part C is saying, now put all your results together, work out the relative frequency of tails as. Yes, you can do that. Please do. Please do. If you manage to do the experiment, please tell me the results that you got. That will be really interesting. Please tell me if you manage to toss the coin 20 times. Please tell me the results that you got. It's okay. It's okay. It's okay. If you don't have coins, it's okay. We just proceed. Like, we'll get the picture. We'll get the full picture as we proceed. Okay. Let's move on to part D. Part D is saying, do the combined results get closer to 50% than results on their own? Do the combined results get closer to 50% than the results on their own? Okay, this is what I know since I'm a statistician, guys. This is what I know. When you do the experiment more times, the results will become clear to you. What are we saying? This is called, this is called when you do the experiment, yes, you got 11 heads. Basetsana got 11 heads and 9 tails. Basetsana got 11 heads and 9 tails. Can you see that, guys? When you say 11 divided by 20, this number is close to 0.5. When you say 9 divided by 20, this number is even close to 0.5. Do you see that, guys? Do you see that? Okay, so that's basically what we are saying. That's basically what we are saying. So the chances of you getting heads are the same as the chances of you getting tails. That's basically what we are saying. Do you understand that? Okay, so what we were saying here is, do the combined result get closer to 50% than your result on their own? So this is what we are saying. Each individual, each of us, the 26 of us, we will do the experiment with the 20 times. We chose the coin 20 times, then we record our results. We have the number of tails, the number of heads. We record it. Then we want to combine the number of tails that we got, the number of heads that we got. When we do that, the result that we get, it's even closer. It's going to get us even closer to 0.5. This is called law of large numbers. The law of large numbers. The law of large numbers, what it says is, when you do the experiment more, it becomes normal. It approaches the normal distribution. It approaches what it is likely to be. Okay, so what we are saying is, the chances of you getting a 50% when you do 20 trials in comparison when you do 10. When you do 10, the chances of you getting 5 heads and 5 tails are lower than the chances of you getting 20 heads and 20 tails when you do 40 trials. So what it means is, when you do the experiment more, when you do more trials, you are reducing the error. You get it? When you do, this is an experiment. Maths is an experiment. It's a science language, guys. It's a science. So how do we improve the accuracy of our results? By doing more trials. So when we toss the coin, let's say 40 times, the chances of us getting a split result like 20-20 are increased. When we do the trial 100 times, it's even worse. The chances of us getting 50-50 are even increased. So it actually helps for you to do more trials. When you do more trials, the results will approach the expected. So when we do more trials, we are supposed to get the likely results, the more accurate results. Because we know the more accurate result is that the coin is fair. But what does it mean to say the coin is fair? The coin is fair means we are getting 50-50. If we are doing 20 trials, we would expect 10 heads and 10 tails. If we do 100 trials, we will get 50 heads and 50 tails. If we increase the number of trials, we increase the chances of us getting an accurate result. That is what it means there. Okay, let's look at part E. Part E is saying, what is the relative frequency of heads in each case? What is the relative frequency of heads in each case? When we are supposed to do this experiment, then we would count. How many heads did you get? How many heads did you get? How many heads did I get? That is the frequency. That is what they are asking me here. Okay, let's look at another patient. Let's look at another patient. Okay, let's look at activity 7. Let's look at activity 7 here. Activity 7 is saying, most dice cubes, which means that they have 6 identical faces. I'm sure you have played snake and ladder with dice, guys, and you remember dice. Okay, It is also possible to get dice with different numbers of faces. Of course, there are different types. There is one called a tetrahedral. A tetrahedral one has got 4 sides. When we say tetra, tetra means 4. So we are saying a 4-sided dice. Okay. As long as all the faces are the same shape and size, the dice should still be fair. Okay, let's see if okay, I'm using Siabula textbook, guys. I'll get you the links, don't worry. Okay, so as long as all the faces are the same shape and size, the dice should still be fair. Okay, the photograph below shows some dice with 8 faces. So we have different dice here that are different faces. Okay. Okay, so question A says, list the possible outcomes when throwing one of these dice. List the possible outcomes when throwing one of these dice. Okay, so we're just going to talk about the one that we know, the 6-sided one. So the possible outcomes, that is 1, 2, of course up to 6. These are the possible values that we can get when we toss the die. So that is the possible outcome. The possible outcome. When we are talking about possible outcome of an event, that is what answers are we expecting in the event occurs. For example, a day when we are talking about weather, it can be either be rainy, it can be windy, it can be sunny. These are the possible outcomes that we have. These are the possible outcomes that we can have, isn't it? Those are the possible outcomes. So in this event, when we talk about possible outcomes, we are looking at the events that can occur. Okay, the events that can occur. The events that can occur. So the events that can occur is 1, 2, 6. Those are the events that can occur. Let's look at part B. Part B is saying, what are the theoretical chances of throwing a 7 on one of these dices? What are the theoretical chances of throwing a 7? Okay, so guys, I said we are concentrating on the 6-sided die. I can see that there is a die that is got an 8 there, but let's concentrate on this die. So when you have a die that is numbered 1 to 6, and you ask a question like, what are the theoretical chances of throwing a 7 on this die? But since the die does not have a 7, so the probability of you throwing a 7 on this die is the probability of you throwing a 7 on this die. The probability of you throwing a 7 on this die, guys, is 0, because you don't have a 7 here. You don't have a 7 here. So the chances of you throwing, yes, the chances of you throwing a 7 is 0, because you don't have a 7. Okay. Let's move on, guys, to this part here. Let's move on to some questions that might interest us. Let's move on to, let's see. Okay. These are all the examples. Okay, let's look at these questions here. Yes, I'm going to give you an activity to do. Let's see if we can have a question for us to do. Okay, so let's look at this question, guys. Let's look at this question here. Question 1. Let's look at this question 1 here. It says, look at the table given for all the possible outcomes for tossing 2 coins. So this is the outcome we have for tossing 2 coins. So this is what the probability space looks like. This is what we have. This is, yes, we are going to do gambling, guys. Come on, this is a simple question for me. This is a simple question, don't worry. This is a simple question. If you get stuck, we will help you. Okay, let's do this one. Let's do this one. I'm not going to teach you how to gamble. I'm just going to show you that gambling is not good. Okay, let's do this question, guys. It's really simple. Okay, since I have a hand up. Okay, so let's do this question, guys. Yes, I'm going to send you a link, guys. Don't worry. I'm going to send you a link for the textbook. But for the moment, let's do this question and see where it gets us. Okay. Okay, so question A is saying, how many possible outcomes are there altogether? How many possible outcomes are there altogether? How many possible outcomes are there altogether? What are the possible outcomes, guys? Look at the table. Give them for all possible outcomes for tossing 2 coins. All the possible outcomes for tossing 2 coins. How many possible outcomes, guys? Okay, so I'm having 12. Everyone is saying 12, 12. Are you sure, guys? 12. Are you really sure? These are 2 coins. These are 2 coins, guys. Okay, so let's try to understand the question again. So this is what is happening, guys. So this guy, he has got 2 coins. He tosses those 2 coins at the same time. This is what is happening. He tosses all the coins at the same time. Are you still sure it is 12? Oh, come on, guys. These are 4 outcomes. The outcomes, we say, what is an outcome? An outcome is a possible event. An outcome is a possible event. So what are the possible events? The possible event is head-head. This is a possible event. We're not saying a head on its own as an event. The event is when I toss 2 coins, either I'm going to have a head and a head. Yes, yes, I'm going to have a head and a head, a head and a tail and a head, a tail and a tail. So the possible outcomes there being, 4. We have this head as an outcome, head tail as an outcome, tail head as an outcome, tail as an outcome. Okay, so what does that mean? It means we have 4 outcomes. Here we've got what? 4 outcomes, not 12, guys. We have 4 outcomes here. Head and a head is an outcome. Head and a tail is an outcome. Tail and a head is an outcome. Tail and a tail is an outcome. Okay, so an outcome is a possible event, not on its own. We cannot say head on its own is an outcome. Yes, it's okay, Peter. I get it. But do you get it now? Do you get it now? This as a whole, the first coin is showing us a head. The second coin is showing us a head. Yes, that's what it means when we say an outcome. Okay. But when we were dealing with only 1 coin, we could say that, oh, there are many outcomes. Okay, let's move on to part B. Part B is saying, how many possible outcomes are there for getting 2 heads? What do you think, guys? Possible outcomes for you to get 2 heads. Okay, so the table is saying this is the first coin. This is the first coin. This is saying the first coin. This, okay, let me just write. This is the first coin and this is the second coin. Okay, so the result for the first coin is head, the result for the second coin is head, you get the values in here. The value for the first coin is head, the value for the second coin is tail, you get the results in here. The value for the first coin being tail, the value for the second coin being head, you get the results in here. That is what the table is saying. Yes, that's why there are 4 outcomes. That's why there are 4 outcomes, guys. Yes, this is the first coin, head and the tail for the first coin, head and the tail for the second coin, right? So these are the results. Head from the second coin, head from the second coin, the results are in there. Okay, let's look at this one. How many possible outcomes are there for getting 2 heads, guys? How many possible outcomes are there for getting 2 heads? What do you think, guys? Possible outcomes for you to get 2 heads. 1. Yes, there's only one. This one with head and head. This is the only way you're going to get 2 heads. That's the only way you're going to get 2 heads. Okay, let's look at part C. Part C is saying, what is the probability of getting 2 heads? What is the probability of getting 2 heads? Now we want the probability. Okay, so I'm going to write this on my sheet here. Let me show you. Okay, so let's look at this guy. Let's say I'm going to write A is my event. Okay, A is my event, right? Then when I write like this is probability of A. This is what it means. Yes, we do have symbols. When I write it like this, it means probability of A. This is what it means. A is the event, whatever event. If you say probability of 2 heads, whatever the event be. So we are just saying probability of A. A is the event. Be it the probability of getting heads. If you choose your A to be the event, probability of getting heads, you write it as probability of A. A being your event. Okay, so I'm going to show you the formula for calculating probability. The general formula, this is the general formula. N A over N. Okay, don't be confused with the signs, guys. Don't be confused with signs. I'm just trying to make it look nicer. Don't be confused with signs. I'm going to explain the signs for you. N A is equal to number of elements in A. Not sure if you can see that, guys. Okay, and N, that is called the universal set. This is called the universal set. So we are saying number of elements in the universal set. Now I know you guys have a question. What is this universal set he is talking about? What is this universal set he is talking about? The universal set, guys, is the set of all the possible events. This is the set of all the possible events. This is the set of all the possible events. What do I mean when I say the set of all possible events? Okay, I'm going to use the example that I have. So my universal set in this example is going to be head. Okay, this is an element. Again, I have another element, head, tail. Another element, I have tail, head. Here's another element, What else do I have? I have cell, shell is another element. So these are my elements in the set. This is my set. It has got how many elements? 1, 2, 3, 4. But what does the universal set? So what does the universal set means? The universal set is the set of all. Okay, you need to see the formula. Okay, so I'm going to put it in here so that you can see. I'm going to put it there so that you can see. Okay, so we are saying, this is what we are saying, number of elements in the universal set. And we have as the universal set. The universal set is the set of all the possible outcomes. That is the universal set. The set of all the possible outcomes. How you put? Okay, if it doesn't want to talk to me. Okay, so this is what we are saying. Okay, don't worry. I'm just it's just this universal set. You just curl it around. Don't worry about how it looks. You just remember what it means. What it means is all the possible outcomes. That is the universal set. When we say we are in the universe. It's okay if it. It's okay. So what we are saying is this symbol is representing all the elements in the universal set. All the elements in the universal set. We are having all the outcomes. That is the universal set. All the outcomes, all the possible outcomes. So all the possible outcomes we have 1, 2, 3, 4. All the possible outcomes. That is the universal set. Okay, then this A is our event set, right? So what is our event set? Hopefully you have coped. Hopefully you have coped what we have been looking at. So let's go back to the formula. Let's go back to the formula. This is the formula we have. This is the formula we have. So the formula is saying probability of the event. What is the event? Let's go back to the question and look at the event. What is the event, guys? What is the event? So he says, what is the probability of getting 2 heads? So the event here is head, head. That is the event. How many times? So we are saying number of heads, heads over number of universal sets. Okay? This is what I have, guys. This is what I have. Okay? This is what I have for you. Okay, so this is what I have. This is what I have. We are saying number of heads. How many heads? How many heads do we have, guys? How many heads do we have? We have 1. Okay? How many elements in the universal set? How many elements in the universal set? How many elements in the universal set? No, Stormy. Stormy was saying we got what? Yes, we got 4. So this is the probability. This is the probability there. This is the probability. The probability of us having. Yes, no, you're not dumb. You're not dumb. That's why we are here. That's why we are here to learn. Okay? That's why we are here to learn. Don't worry about it. Okay? So we are saying number of heads. We have this. This is a set. We have 1. Number of universal sets. We have 1, 2, 3. That's why we have a 4 here. Okay. So my time is killing me, guys. My time is killing me. Let me just do one last question for you. Let me just do one last question, and we call it a day. Okay. Let's look at this question here. Where is it? Okay, let's look at part D, guys. Let's look at part D. Let's look at part D. Let's look at part D. Part D is saying the probability of getting, yes, when we are being asked to find the probability, it's done. It's done like this. What they are asking us, what is the probability of getting 2 heads? The probability of getting 2 heads, we say, how many times is the probability of, how many times is the event 2 heads happening? How many times is the event 2 heads happening? We see that it is happening once, isn't it? It is happening once. Then we divide by the possible outcomes, the number of ways that we can get. We can have head, 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 tail, tail, head, tail, tail. These are all outcomes. Okay, so let's move on to the last question for the day. Our time is killing us, guys. Okay. Okay, let's look at this. Is that probability of getting 2 ears the same as the probability of getting 2 tails? What do you think, guys? Is the probability of getting 2 ears the same as the probability of getting 2 tails? What do you think? What do you think, guys? Yes, it is, right? Because you have the same number of getting tails is the same, isn't it? Yes, you are so clever, you guys. You're really smart. Okay, let's just finish this question then. Okay, let's look at part E. How many possible outcomes are there for getting 1 head and 1 tail in any order? How many, guys? Okay, we need the event. What is the event? Event is head and tail. But we have told that it happens in any order. You can have head, tail, and tail, head. How many times? How many times are we getting head and tail? Yes, we are getting 2 here. Then this one is not changing. This one is not changing, guys. This one is not changing. So we are getting 2/4, which is 1/2. Yes. Yes, Pete got that one. Pete got that one. Okay. Okay, guys. My time is killing me. It has been wonderful teaching you guys. I really enjoy teaching you. Yes, it is 50%. It is 50%, guys. Okay, so you go and take a look at these questions. Yes, thank you, Pete. Enjoy your day too. Okay, you going to get question F. If you can figure out that one, we'll continue from there tomorrow. Okay, have a great day, guys. Goodbye.